Hi guys, I hope you're good since last video. So this time we're gonna actually draw this diagram to explain how GitLab agent are deployed and are handling the application deployment process in an automated way using GitLab server, some use cases. And here we have our cluster. We're just gonna check kubectl get pods in the namespace Creditizens. This is our pod, that's the Nginx pod. So we're gonna exec to it to check if our GitLab deployment using the GitLab agent did work or not. And that's what we're gonna see during this video. Here we go, I'm just gonna fast forward the drawing of the diagram, and after we're gonna pause a bit and explain the different components of this diagram. It's good to have the image just to have an overview of how everything works. Here we go. So we have on the left side the GitLab server and on the right side the cluster. Let's focus first on the GitLab server. Inside we have different components. We have our repository. That's where the developer team is going to be pushing the different files. We have the GitLab operator, which has been prepared and the setup has been done by the DevOps team. And we have the config YAML, the file mapping to the repository folder. So the GitLab operator is going to use this config file YAML to know which folders in the repository it will have to monitor in order to take those deployments and deployments configs and use the gRPC communication to deploy it to Kubernetes. So yes, in between we have a gRPC communication between the GitLab server and the Kubernetes cluster. After we have the controller node. Here it's an example with one controller and the two worker nodes. So the controller node is going to be actually deploying all the different applications sent by the GitLab operator. But before that we need to deploy the two different pods. Here I've just used two, but we can use more replicas if you want, using Helm. So Helm to deploy the GitLab agent. The GitLab agent, to deploy them, you will be actually communicating, telling where is the server, so giving the IP address or the DNS of the server. You can also say how many replicas you want, so there's different variables to fill. And after that, we're going to do your deployment and you're going to get your pods running. At the time the pods are running, they'll be listening to the GitLab server using this gRPC communication. Okay, now let's just focus here on a use case. So the developer team, they changed the file in the repository, so they did the git push. After that, we have the GitLab server, the operator, the GitLab agent operator. So GitLab servers agent operator detects it's instantly, so it's going to be mapped to that repository folder, and it's going to be able to see that something has changed. At this time, the agent operator, there will be some typos, but just don't focus on those, just to get how it works. So the agent operator sends to the cluster the deployment configs using the gRPC. So there's active communication actually. The pods, the GitLab agent pods, are going to be listening to the server. So they'll be able to pick up those changes. Kubernetes controller use the agent pods to deploy in the cluster. Basically, whenever you make a change to those YAML files, you are going to get the change deployed to the cluster. Here, the user also at the end of the loop have access to the application. What we can do another use case really quickly. I'm just going to copy this. This is going to be almost the same, but there'll be some little differences. For example, at the beginning, let's say this time, developers, they delete, or the developer deletes the YAML file, the deployment. So the file is not anymore in the repository, in this commit. So after that, we still have the GitLab, the agent, which is in communication, which is connected to that folder. But here, what is going to change is here, the agent operator is going to be indicating to the cluster that there's nothing in this folder. The folder is empty now. The Kubernetes controller uses the agents pods to clean everything. And here, the user don't have any more access to that application. But talking about this user actually having access to the application will be internal to the cluster. If you want to make it available outside, you need to use node port, ingress controller, or load balancer. So here, just an example really quick of node port. So let's say that you have your cluster node, the namespace Creditizens, where there is the pod, here for example Nginx, exposing the port 80. It can be any application, but this pod needs to be mapped by a service called node port. So this service have communication to the backend application, and in the front end, it will be exposing another port. For example, here the 30080, and this 30080 port is going to be used by the people outside of the cluster, so the public is going to be using the node DNS or the IP, the port exposed, which is here 30080. So by doing that, they'll be able to access to the backend application and use it. So this is on-premises, what I'm doing now, but you have the load balancer on AWS, for example, that you can use, or ingress controllers like Nginx. So now we're going to go in the repository. In the Operate tab, Kubernetes clusters, and here we have the agent. So that's where we get this connection. We can see the status connected. The last contact is 1 minute ago. We have the version, the agent ID, and the configuration file. You can see here it's in a .gitlab/agents, and after I give it just a name, Kubernetes agent. Click on it. This is the config.yaml file. That's the one which is going to be mapping, and here it's in the folder, in the .gitlab folder /agents, and the Kubernetes agents. Here we have the ID of the repository, which is referenced. And here's the namespace where the GitLab agents are deployed. And here we have the different paths. So in the repository where it will be able to find those YAML files, deployment YAML files too. So here is using regex just to tell that it can be also a JSON file or YAML file. So let's go to the repository, the root. We have on the top the .gitlab having the configurations. Some different other folders. Inside those folders there's nothing, so there's no config files at the moment. So during the tests I just called one default namespace and the other one I give it another name to deploy, but here we're just gonna be doing our own file, the Creditizens namespace. Now let's go to the controller. Just kubectl get all namespaces just to have an overview. of what we have. CTL, get namespaces. Those are the namespaces that we have. You have the agent. Those are the default, namespaces when you have your cluster setup. Get the replica sets, all namespaces, just to make it quick, just to show you that here the GitLab agents, those ones, the GitLab namespace, they have 2 replicas. So we have 2 replicas. Just check in which node where they are deployed. So it's good to have an overview before showing you the example after and how to make your deployment. So let's get the namespace. Name is a bit long. I'll make it shorter next time. It's very descriptive. Okay, here, kubectl, get pods. In this namespace, we have only 2 pods. Let's put the O wide so that we can see they're running, and one is in worker 2 and the other one is in worker 1. So each of the workers, they have one GitLab agent. Let's go back. Server here. This is the GitLab CAS, so that we can also see what is happening whenever we deploy. GitLab CAS is the GitLab configuration that is going to be actually having those gRPC communication. That's the component having the gRPC communication with the Kubernetes cluster. So here we're going to be in watch mode. We're just going to prepare everything. So we got the logs and we can see what's happening live. And here, let's get the logs of one of the agent. In the namespace, GitLab agent, Kubernetes agent. Okay, so now we get the logs here. So that's what we did in the past. So we will be able now to use just this command again to check on the logs. So you can check on the logs just to see what does the GitLab agent do. Okay, the CAS is ready. So now let's go in our, so there's the GitLab CAS. I'm just going to show you here is using the gRPC method here, and here is a config file. We create a namespace called the Creditizens, and after we're going to deploy Nginx, one replica of Nginx. Okay, so everything is set. We can commit this change. That's good. Commit is done. So now the automation starts. So this is our GitLab CAS showing us here. You can see the commit number 8F1DA6FF, 8F1DA6FF. You can see it here. And now you can see here in the watch mode that we have the deployment is running, and you can see the different stages: pending, container creating, and after running. And here we can maybe check. Let's see, where is the command? The namespace Creditizens has been created, which is perfect. That's what we want. This is running. Now let's check the pods in the namespace Creditizens. So that's what we've seen at the beginning of the video, and now let's see how it's gonna be. We have our Nginx deployment. That's good, it's running, and now let's execute it. So let's go inside the pod by using the command kubectl exec it, the option it, in the namespace Creditizens. Let's use bash to have our terminal. So we're inside in the terminal. We're gonna check if Nginx is working. Just let's curl the local hosts, and here we go. So here we're doing it inside the pod because we didn't set any node port. But I hope that you liked this video, and that you'll be able to understand how it works and deploy your application using this system. It can be easy, and also it can help developers to use their own environment, their own branch to deploy their application and do testing using this technique. Okay, see you next time.